But I'll start with an example that really has nothing to do with investing, an example of how artificial intelligence is changing different fields. Uh, and this example is from game playing. And games, it turns out, are a great test bed when researchers are developing and then when they're trying to evaluate different methodologies for machine learning. This is an example of a game called Go. It's an ancient Chinese board game. It's at least 2,000 years old. And Go is interesting for machine learning researchers because unlike chess, which is a complicated game, but the number of legal positions is small enough that you can still at any point evaluate a vast number of moves and pick the best one. Go is many, many orders of magnitude more complex than chess. And so that strategy doesn't really work. You can't just evaluate a large number of moves with really fast computers. With Go, you need to take a different approach. And so a group of researchers at a firm called DeepMind, it was a London-based firm, it was acquired by Google. In 2014, they decided they would create an AI, a machine learning algorithm that would be able to beat the best human players in the world at Go. And they applied something called deep learning. It's a form of neural network, which is a machine learning technique that's based on the way that neurons learn in the human brain. And they applied deep learning, which basically means having the computer play against itself many, many millions of games. And the computer gradually learns what sorts of patterns constitute good moves in the game. And they were successful with this. So by 2015, they developed a system that was capable of beating the European reigning champion, a guy named Fan Hui. So they won in that match. They went on to work on the model a bit more. And then in 2016, all of this culminated in a five-game match against a player who's considered one of the greatest players of all time, world champion Lee Sedol of Korea. And the computer defeated Lee Sedol in a score of 4-1. So it was a huge success for the AlphaGo team at DeepMind. And one of the things that comes out when you look at these pictures of human players, sort of getting to this question of what's the role of people once machines have come into the picture, you can see the anguish on their faces as they're losing. And there's a great documentary called AlphaGo that describes the development of the system and these matches that it played. And the way that the players, after their defeat, they describe playing the machine. They express frustration that any move that they play, the machine seems to have a perfect response. And then even more interestingly, they made the comment that what they saw from the computer was moves that they would never expect, moves that they didn't understand, and then realized later on that it was a very effective move. And they said that it looked as though the machine was playing with creativity, which is something that hasn't been said of previous chess playing machines. And so this frustration leads to the natural question, does this mean that humans really have no place in Go? And we can think about that, by analogy to other fields like investing. But I want to draw attention to two facts about AlphaGo. One is that these systems are not constructed out of thin air. It takes a big group of people to build these systems. So when you look at AlphaGo, they eventually published an article in Nature describing how their algorithm worked and describing these matches that it played. And that article had 20 co-authors. So it's a very large team of people building these systems. They're not folks who have been playing Go since they were kids. Most of these are engineers and computer scientists, but nevertheless, there are still people behind the development of these technologies. And those people, it turns out, don't just build the technology, then they go on to maintain and enhance it. So there are always going to be people involved in the process. And then the second point is, if you look at these pictures, you'll see that this defeated European champion, Fan Hui, he was actually hired by the AlphaGo team after he lost to help make the model better. So they understood that they would need someone who had been playing the game since he was a kid to instill all sorts of fundamental knowledge about the game of Go into the computer and to help them make the model stronger so that it could beat even stronger players. And so there's also a role for what we would refer to as domain experts, people who have a knowledge of the subject matter, and they can help to guide the development of intelligent systems that ultimately just serve as an extension of our human capabilities that make our work faster and better. Now, not surprisingly, Wall Street has been eager to adopt a lot of these new technologies and apply those to make even more money. And we've seen an explosion. This has been going on for at least 10 years now, but it's really accelerated in the last few years of interest in machine learning applied to financial markets. So lots of books being published about machine learning in finance, conferences, webinars, articles in the popular press, academic journals. If you look at top finance journals now, very often they'll publish papers that that make use of machine learning and other big data methodologies. The chart on the right, this is a study that was done of keywords in finance, academic finance articles. And you can see there's been almost exponential growth in the last few years in terms of the number of times these machine learning related keywords come up. Interestingly, the top keyword, neural networks, this is a technology that's been around for a long time. People have been trying to apply this in finance for quite some time. This is the methodology that the AlphaGo team used. It was a form of neural network. But one of the things that we found as we've observed machine learning being adopted in finance and for investing in particular, is that it hasn't always been very successful. And there are reasons that machine learning, as much as it's promised to revolutionize the way that we invest, that it hasn't always lived up to that hype.